Okay guys, if you've watched Dealing with Log Graphs video, then you're ready to kind of go back and have a look at this that was in the homework. If you've already figured it out, that's great. It's just looking at that in a little bit of depth, that's all. So it's back into our safe world. We're doing capacitors, it's stuff that we've learnt about and so on. There's a bit of a description of what's going on. The student timed it for 15 seconds and then recorded the reading on the voltmeter. So you've got your discharge curve there, discharge equation there, fairly straightforward. And the first bit is just to show what's going on. It's a graph, so again we're going to flatten this out to make it two things added together will equal a third. So log of v, again natural log will means it can get rid of the e and make it the simpler version, so log of v naught minus t over CR, except t is 15 seconds. Okay, so actually I'm going to change that to 15 over CR. Now that is a constant on its own. There's two variables in there, so what we're going to do is split them apart and you end up with equals log of v naught minus 15 over c, it's already telling you the answer there, times by 1 over r. So if you plot 1 over r on the axis, then what we can get is your gradient from that. Okay, sorry, 1 over that on the x-axis, read the data, x-axis, then that's going to be your gradient. It's going to be a negative gradient of that value. That's going to be your plus c. So you're adding in that constant, and back over here is going to be what's on your y-axis. Okay, so two things multiply together. One of them's gradient, one of them's the variable that you plot. The table, as I said in that other video, what you need to do is do the full version to work out give or take on these. So if you're finding the log of v when it's in volts, so that's in volts, don't need to do any change, you wouldn't expect to, just be a little wary though. So the log of 3, that's going to give you 1.0986. It's only three significant figures, so that rounds to 1.10. And what you're going to do is find the log of 3.2 and the log of 2.8. The difference between them is the range. You want half the range, and half of the range will give you 0.07, which happens to fit in with a realistic pattern. So that's looking okay. Okay, so the log of 3.2, log of 2.8, that's the difference between them, and you half it. That's going to give you a graph. So again, as I said in that last piece, what you're trying to do is make it easy for yourself. So I've already marked on. You need to check out the scale, think about it. So there's 1, 1.2, 1.1. So each one is 2 squares. Sorry, each square is worth 0.2. Yeah, so the scale's not brilliant. If you're checking on these, if you're ever not sure and they've got these, then they'll give them to you. So if we look at this one, for example, let's go for the number 10. Number 10 is give or take 0.04. So 0.04 is 2 squares, so that must be 0.02. So again, it's that version of 2 scale factor. I've drawn a line across here for my first one because it is not the one I've just calculated, but they haven't done it for you. So 1.3, 1.31. So I'm going to put little lines, just make it convenient. That's at 15 seconds, so I'm going to go up from 15, and I can see quite easily then. Yeah, I'm not trying to make my life hard. So there's my dot, or my little bar, and you're going to go up 0.06. So that's actually going to be 3 squares. 1, 2, 3. And down squares. 1, 2, 3. That's the midpoint, because that's the midpoint. So there's your error bar. It's pretty big. And the one that you've just calculated is at 18 seconds. So again, put a mark on. It's at 1.1, so that's actually more easy to see, but again, take your lines across. There we go. So what we want is 1 there, and then it's going to go up 0.07, so that's 3.5 squares. There we go. And down 1, 2, 3.5 squares. Okay, and there's your error bar. So that's how you get them in, how you work them out, find the actual values, log them, and that's going to give you your two extremes on your bar anyway. If you then take your ruler, you'll find with your standard experiment where the values are getting bigger, therefore the uncertainty is getting bigger, usually because it's some sort of timing thing, then what you'll find is you'll end up with a load of lines of best fit and worst fit. So, to be clear, line of worst fit is the steepest line, so it's going to go to the top of the highest bar, bottom of the lowest bar, as long as it goes through all the others. Now, just be wary, that one is actually higher up. So it's not going to go to the bottom of the last one, but it is going to go through all of those. Okay, so only just. And again, the opposite is also a line of worst fit, so let's just take that, let's go to that. Are we going through all of our bars? Yes, we are. So therefore, there you go. So those are our lines of worst fit. They're going through each of our error bars still, including one at the top. Great. So they fit, but they're obviously not down the middle. They're the worst ones. So what you can do is you don't actually need to work out the middle value. You can find the gradients of those two. And again, make your life easy. Carry on with that line. Get it to the axis. Unfortunately, that one's not going to reach the axis. Never mind. But again, find nice convenient things. So there's a mark. That works. That's crossing at a nice good place. Both of those at the top ends, they're both crossing in good places. That one's not so good. I'm going to go for there instead. And again, I'm going to mark it to make my life easy. So you might want to put it on. That's 2.1. And that's going to be 2. Oh, notice it's a false 0. So that's going to be 2.5. That's 3. 3. Let's get the markings. So 3, 4. So every 4 squares is a whole unit. So that's going to be 3 1/4. Yep, just check on that. 3.25. Okay, so I've got my values for working out those. That one's not too bad. That's that was wrong. What am I saying? 2.04. 2.1 is halfway up, isn't it? So that's going to be 2.16. So label them on. No one's going to worry. That's going to be 18, so that's nice and easy. This value here is going to be 1.04, and just make your life easy. So, if you find the gradients of those, you'll have gradient 1. If you subtract gradient 2, it's going to give you a range. Okay. And if you divide them by 2, that will give you your uncertainty in your final value. Now you're probably not going to need it here straight away. No, you want it down below. However, if you do gradient 1 plus gradient 2 and then divide by 2, you're going to find the average. Okay, and that will be your value of average gradient. And as we saw in the first half of the question, I've lost it, then average gradient, can't spell, equals 15/c. Yeah, so if you do 15 divided by average gradient, you'll end up with c. Your plus and minus, no, it will be here, there we go, there's your plus and minus, comes straight into that. And that's going to come into here. Excuse me, that's not very clear. So that's going into there, that's going into here. And your unit is just its capacitance. So it's going to be in farads. Let's double check with everything. Yep, looking all good. Oh, and this is the question. Okay, all you have is your resistance is in 10 to the minus 6. Okay, so just be wary of what units are. That's fine, that's in volts, it's the log of PD in volts, but that gradient is actually going to be really large value, which makes sense because it's going to be really small capacitance. It's going to be, you know, milli, micro, farads, something like that. Okay, so just check your gradient is of the right values using those, etc. And that really is the crux of the question. The last part of it, find the value of R in kilohertz for which the capacitor discharges to 10% of its original value. Well, you can't take it off here because you've got that problem. It's in logs, sorry, it's a log scale, so it's not going to be 10% of that value. What all you're after is, you're going to have to just substitute it back into your original equation, I would suspect, in that version. So again, don't forget you got 15, because it was 15 seconds. It's going to give you value from your value of C, you substitute it in, you want discharges to 10%, so you're going to have basically V over V0 will equal 10% of it, so 0.1 V0, that's 10% divided by V0, so 0.1 equals e to the minus t over CR, where that is 15, that is your value from here, and your value for R is what you're after. Okay, so let's base it out. Log, point that, will give us minus 15 over CR, and again C you know the value of, so you just need to find R. Okay, good luck with that, guys.